Do what? We'll determine number of solutions the system equation has and solve the system by graphing. Just make sure you get that down. Make sure that you get the heading down also, okay? So you know what to refer back to. Guys got that? Yeah, nay. Anybody need more time? Okay. First question, or first part here. Okay, now, when we're talking about systems, what does a system mean? When you hear the word system, what does that mean? Just anything. Just take it anything in general. Why you do something? What else? Process. Okay, what else? Hey, you have a system of things. What do you have? Look at this. Yeah, but if you have a system of things, I think of a place that makes Coke. You have a system, right? Are there a bunch of things within that system?
Yeah.
Yeah, I mean, there's a whole bunch of things working together, right? Okay, so write this definition down. A system is basically multiple items. Okay, in this case, we're dealing with what? What have we been working with the last couple weeks? Last few weeks. Graphing lines, what else? Slopes, ordered pairs, all that, okay? All right. Here's what you need to know about this. It's basically, you're going to have two or more equations, right? In our part, we're just going to do mostly with two. Now, when you get up into your Algebra 3 or Algebra 2 classes, you're going to have like 3, sometimes 4, that you're going to have to graph, okay, and do other stuff with. Right here, number of solutions, exactly one. What happens when you have exactly one solution? What are these two lines doing? They cross, they intersect, don't they? Okay? So the terminology that we use is that these two lines are consistent and independent of each other. Guys got that? Yeah. You're going to be asked up. I mean, I have to tell you to write something down all the time?
No, I'm not gonna.
Okay, in the middle part, what's happening here? What do you think infinite means? How many lines does it appear that you have right there? And in reality, you have how many? You have at least how many? No. What do we say? We're working with what? Systems, which is multiple what? Multiple items or multiple lines. These two, there's actually two lines here. What's happening to the two lines? They are falling on top of each other. Okay? What does it mean by infinite number of solutions? If I were to draw a whole bunch of points on this line, what would happen? Those points would do what? Would they fit in both equations? Yes, they would. What's going to happen here with just one solution? That ordered pair is only going to work in what? It'll work in both lines, right? If I draw a point out here on this line, is that point going to work for the other line? It's not going to, is it? So when it's talking about exactly one solution, it's where both of those lines intersect. What do you notice about the third one? What scenario would you have no solution? Right, which makes them what kind of lines? What do these two lines look like they are? Parallel, good. So you get parallel lines, those two lines are never going to intersect, are they? Okay, so they're never going to have a solution. Are they still considered a system? Yeah. Okay, here's what you need to know. You need to know the terminology. I would draw the diagrams too. And if you just want to put a couple lines intersecting, do that. But you need to draw the diagrams. What means what? Terminology that you're going to need to be familiar with is consistent, independent, consistent, dependent, and inconsistent. I'm going to have some questions here in a second that are going to go over those. So make sure you get that whole diagram written down. So you get one of this. Okay, anybody need more time? All right. Use the graph to determine whether the system is consistent, inconsistent, or if it's independent or dependent. What is it? What are the two lines doing? Okay. They're parallel. Now, are we going with positive? Are we absolutely positive that they're parallel? What do we need to check? Now, I would check the slopes of each one of the equations, right? Okay, so if you notice right here, that slope is -1. And one thing you also got to make sure is that both equations are what? Are they both in the right form?
Yeah.
Okay, good. So the slopes, are they the same? Okay, then these lines I know for sure. What's my answer? Inconsistent. What else can I say? Very good. Who said that? No solution. Okay. Use graph. What about these two? How many lines do you have there? You sure? How many boxes? There's 3 boxes, aren't there? So what's happening with this one and this one right here? They're on top of each other, aren't they? Even though the equations look different, they are what? The same, aren't they? You guys see that? Okay? That's one thing that you gotta make sure of, okay? It just looks like there's 2 lines, but in actuality, there's 3. Okay, so a couple of those lines might fall on top of each other. That's one thing that you gotta pay attention to, watch for. Okay? Now, the 2 lines that they want us to check are which ones? This one right here? Okay. Then the other one, right? Okay, so those 2 lines do what? Do they intersect? Okay, so what's my answer here? Yeah, consistent and independent. Now, let me ask you a question. You're gonna need to know this too. Where did these 2 lines, if there's one solution, where did these 2 lines intersect? What is the solution of the 2 lines? Right. What is the address for that? It's what? 2 and -1. So that's going to be the solution. That's the point where those 2 lines intersect. You guys with me? Now, how can I check for sure? Very good, Jasmine. We can plug it back into both of the equations and see if it works, right? What should occur? The left side equals the right side. Okay? We can always check that. All right. Answer this one on your clickers. Use the graph to determine whether the system is consistent, inconsistent, and if it is independent or dependent. And one nice thing here is the first equation's in what form? It's in standard form, isn't it? Now, do I need to get slope-intercept form? Well, they tell me what the line is, though, don't they? Okay, this equation right here is this line. And then the other equation is going to be what? This line right here. You guys see it? Okay, I don't think everybody's logged in. Who's not logged in? But really, it shouldn't take you that long to answer these. Make sure that you're writing your answer choices on your cards. Keep trying. You know, you log in. Okay, answer this one. Okay. Next problem. Write the system of equations. What you need to do is write the two equations down. Like these two right here. Okay, write the system of equations to determine whether the system has no solution one or infinite many. If the solution or if the system has one solution, let's name it. Okay, now, can I graph the first equation? Okay, now sometimes it may be helpful if you guys go ahead and label it. A and B. Okay, can I graph the second equation?
No.
So what do I need to do with it first? Change it, right? Okay, so how do I change it? You guys walk me through it. Right? Now what?
Divide by -4 and 3.
Can I write this down? What's that give me? No, it's plus 3. Negative divided by negative gives me a positive or a plus, right? Okay, now what do you notice about the two equations? They're exactly what? Same slope, same what? Y-intercept. So these lines are going to do what? Okay, so if they're on top of each other, that means how many solutions do I have? Do I need to graph them? Not what it's asking me for. What's the answer? Infinite what? Infinity. Got to see how that works? So a lot of times you can, if you get both of the equations in slope-intercept form, you can compare the slopes. Okay? Do these. Okay, equation A, equation B. What form are they in? Standard, so let's get them in -2y equals -1x plus 4, then divide by -2, y equals 1/2 x minus 2. Do the other one. What would that be? Plus 1? Okay, what do you notice about these two equations? You're right. Same slope, different y-intercept. So what's going to happen with these two lines? They're going to be parallel. Very good. Which means I have, how many solutions will I have? None. No solution. They're not ever going to intersect across. Okay? So I don't need to graph it, do I? I mean, it's not based on what they're asking me for. Does everybody see what's happening here? Everybody kind of Is it? Answer that one. Okay, number 4. Okay. Next one. How do we apply? Okay, Naresh and Diogo are riding their bicycles to get in shape. Naresh rode 20 miles last week and plans to ride 35 miles per week. What's 35 miles per week? If I were to put these in an equation, yeah, but what would that be? That'd be my slow, good, my rate of change, right? Okay. The 20 miles, what would that represent? The y-intercept. That's the starting point, isn't it? Okay, so right down here in Naresh, y equals 35 times x plus 20. That's my first equation. And you guys understand, how many people do I have? I have 2 people. How many lines am I gonna have? 2. Y'all see it? Write this down. Write these equations down. I would say Naresh, make sure you write his name down. And then write Diego down. Diego, what did he do?
Drove 50 miles. Last week.
Good. So he's starting from the 50 that he's already done. Now this week he plans on doing how much? 25 per week, right? That's good? Got it? Okay, so now, drop the equations, y equals 35x plus 20 and y equals 25x plus 3. I went ahead and did that for you, okay? Notice my y-intercept, what axis is this? It's y, right? Where does my red line, where's it crossing? Okay, so that's my y-intercept, right? Where's this line? 20, that's my y-intercept, right? What does the y-axis represent? Starting point. 4 miles, right? Number of miles. What's the x-axis represent? Number of weeks, right? Okay, so at what point are these 2 lines, these 2 riders, when are they going to ride the same amount? My lines are going to do what? These guys are riding, and all of a sudden they do what? They meet up at a certain point, don't they? Would that be the same amount that they've traveled? Okay, so where's that point crossing? Right in there, right? Okay, so the graphs appear to intersect at the point with the coordinates what? 3 and 125. Now, check this estimate by replacing x with 3 and y with 125. So I can check and see if it's gonna fit, right? What's gonna occur? That ordered pair's gotta be what? It's gotta fit both equations, right? So take the first one, equation A. 125 equals 35 times what? 3 plus 125. Oh, no, I'm sorry. Plus what? 20, good. Okay, so 125, what's 35 times 30? 105 plus 20. Good. So now, the left side equals the right side. So it fits for that one, doesn't it? See if it fits for the equation B. Okay, so 125 equals 25 times 3 again, plus what? 25 times 3 plus 50. So it works. Now, just want a little bit of advice when you guys start graphing your lines to see if they intersect. You might want to use a ruler, okay? Because it'll give you a pretty good ballpark where the answer is going to be, okay? A lot better picture of where those 2 lines intersect. So when you graph today, make sure you use a ruler, okay? All right. Answer this one real quick.
Blake, Brandon, you guys still working? You guys should already been done with it. I get your graph. Your graph's already graphed for you. Okay, let's see how we did. Okay, why would it not be A? Yeah, what's on this side? This is the money, right? Okay. What's on the bottom? What are we looking for? Weeks, right? Good. Why is it not C? Yeah, these two lines don't lie on each other, do they? They intersect at how many points? 0.3, just 1 point right here. Okay. Which two lines are we looking at?
The x minus 1 and the x plus 4.
Okay, so this one right here, right? And this one right here, right? Okay, what do you notice about these two lines? What's the slope right here?
1.
What's the slope here?
1.
So they are for sure parallel, aren't they? What should your answer be here? B, right? Okay, so you got this line here, right? And this line right here. What's the answer? Consistent and independent. Good. It's not inconsistent. It's not the same lines. It's this line here and this line here, right? Okay.
All right.
Okay, so now let's look at these first couple problems on your third check. What are the instructions asking you to do?
Graph each system and determine the number of solutions.
Okay, so we may or may not have to graph them, right? Let's go ahead and look. First of all, I gotta get them in what form? So we've got equation A, equation B. A is gonna be y equals negative 3x minus 3, right?
Yeah.
B is gonna be, so these two lines are parallel, good. How many solutions? So now, do I necessarily need to graph them? Okay, what about the next one?
We gotta change the first one.
Okay, so change it for me.
Subtraction and divide by
So it'll be y, negative y equals negative 2x plus 1.
and more positive. Oh yeah. Sorry.
Oops. And so y equals 2x minus 1. Good? Okay, so what's my starting point on equation A? Negative 1, okay, so right here. So a point, then go,
Up to, over, to the right hand.
that's what we, I don't know if I can do it. Oh, yeah. Okay, what kind of line is equation B? Good, we're at,
It's at negative 3.
okay, where do you think these two lines, how many solutions do they have? One solution, right? Where is that? Negative 1 and, what do I need to do? Plug it in, check for sure, right? Now look at your second equation, this one's is pretty easy, okay? What do I put in there?
Negative 3.
Yeah, so -3 equal -3. So it works for that one, doesn't it? I don't even have to worry about the x coordinate. Now, if I want to plug it back in, does it matter which equation I use? Can I use this one? Can I use that one? I can use either one, right? Which one would you guys prefer to use?
Do slope.
This one? Either way, it doesn't matter. -3 equals 2 times -1 minus 1. So it works, doesn't it? Okay, so this is my answer. Yeah, there's a whole bunch over there in that plastic tote, bin, whatever. Right in the middle. Is everybody good on that? Okay. What's the deal on this one? This is number 3, isn't it? This number 3 here? Okay. So I don't have to do anything to the first equation, do I?
No.
And what about B? It's gonna be what?
Y equals negative x plus 2.
What's the answer? Or the same, aren't they? What does that mean then, Jasmine? Very good. Infinite solutions. All right. Is it number 4? Okay, let's do that. Equation A, equation B. We got y equals x minus 1. B would be what? Y equals negative x plus 3. Okay, what do you notice about the slopes?
We're off.
Opposite what? Reciprocals. So it makes the lines what? Perpendicular. Now, we have to figure out where they're perpendicular at, right? Where they intersect. So I'm going to have to graph these. Start at -1. This is equation A. Go up 1, right 1. Okay, equation B. Starts at 3, so 1, 2, 3. Down 1, right 1. Okay, where do they intersect?
2, 1.
2 and 1. Get our check. Put 1 in for that. And then green. Okay, so put 1 in for y, 2 for x. 2 minus 1. So it'll work on that one, right?
Yes.
Okay, put 1 in for y, 2 in for that. -2 plus 3. So it's gonna work there. So that's my solution. Okay? Everybody see how that works? And don't forget, what do you have tomorrow? We'll do a worksheet, right? Kind of reteach or if we need to, or kind of review. We'll use the worksheet for the review, and then we're going to take a daily quiz. Okay? Give it to me.